Takes forever. Because, you know, like the one where you're adding the two matrices together, I still have to check every number in the matrix, and so it's a pain, so I'm very pleased to be done with it that way. But there are a number of people in here whose grades in the first semester were not as high as they hoped, and then all of a sudden, it's starting to change for them. That's true with a few people in here. And do you know what I attribute that to? It starts with an H.
Homework.
Homework. Okay? There are some people whose grades were very good in here. They're starting to fade some. Do you know what I attribute that to?
Homework.
I'm overgeneralizing. There is no doubt about it, and I'm sure that there is not a 100% correlation. But it will become, and I've said this a few times, I'll say it once more, it will continue to become a bigger deal. And it'll get bigger and bigger and bigger and bigger. And so, for those whose grades have not gotten off to a great start, understand where we're coming from and understand what you have to do. Right? Right. Okay. What's the other thing I was going to say? There's something else I was going to say. But I don't remember what it was. Oh! For those whose grades aren't where they want them right now, also remember that's one test. Remember that it's a long semester. We have, still before the end of the quarter, we have 2 tests and a quiz coming up. Then in the fourth quarter, we have a quiz, a project, a test, another quiz, another test, another test, another test. So we have 1, 2, 3, 4 tests, 2 quizzes, and a project next quarter.
Wow.
We talked about this the first day. You guys see it on your calendar. You guys. Okay. My point is, there's a lot to go. Don't freak out yet. But keep making adjustments. Do what you're supposed to do. Like
Homework.
questions on the homework. Sir. 60. I'm going to start, before we do 60, I'm going to start by talking about 55 for a second. Don't do it. I hate that problem. I can't believe that I left it on the list. I apologize. I took it off for next year. It's a terrible question. Move on. Okay? Whatever the heck they are. Hey, number 60. This was the hardest homework?
That one question.
60?
Yeah, for me. I sat there staring at playing out.
What is the one thing that I would ask you to do in question number 60? Get it to one thing. So here's the deal on number 60. Okay? There are really, if you look at it and go, what the heck? There are 2 ways you can proceed. Way number 1 is you can do the 12-year-old thing and say,
Nope.
I don't know how to do this, I'll let him show me. And method number 2 is you can say, I'm going to start writing some stuff down that I know, and maybe at some point something will click. I'm going to at least put everything I can into it and see what happens. And when I say everything, I'm not saying spend a half an hour on it, but I am saying do what you know you can do. For instance, it's a mixture problem. As soon as we talk about a mixture problem, what do you know is coming? A chart. We can draw the chart. You have already not left the question blank. I appreciate that. Is there anything that you can fill in on the chart? The stuff across the top. What goes across the top? Amount. Times. Percent of
us too.
We want the mixture to be 4% oil and the other mixture to be 2.5% oil. Therefore, it would make sense if this was percent oil. I would agree. Equals, and what goes here? Total. Yeah, total oil. That's fine. Okay, so you're already somewhere, which I appreciate. What typically goes down the left side? The ingredients. What are the things that we are mixing together?
Oil, gas.
So, let's see, gas is listed first, so I'll put gas here. What's next? Oil. Those are the things we're mixing together. Then what?
Mixture.
Okay, but there's one minor problem here. I'm talking about the problem here. I'm not talking about any real world ramifications that we think that gas and oil don't mix and stuff like that. They do, by the way.
I know, it's water.
It's what?
Gas and oil mixed to form water?
No.
Oh, okay. By the way, gas and oil do mix. Oh yeah, that's right, it's water. You understand where I could get confused by that? Okay. All right, no, it's all good. What's the problem?
He wants to know the bottom line.
Is it because there's two pictures of speaking from the
That's exactly the problem that I would look at. You know, we're looking at one more spot because what's this supposed to be? Yeah, the result, right? We mix some of this, we mix some of this, we get some of this. But the problem here is that we have two of these. So, make what? Not two tables, but another row. Would another row take care of that? Well, let's see. Let's try it, see what happens, see if it works. So what goes here then?
4%?
The 4%? And what goes here? 2.5%. Okay. We've done one thing that was a little different, and that was adding the extra row. But look at what we have now. Is it something we can work with? Yeah, so you've already gotten somewhere. You know what I mean? You've gotten somewhere. And now we have a chart. Can we fill stuff in on the chart? Is there anything that's obvious? The amount of gas and oil. How much gas? How amount? 340 gallons of gas. Oil? 10, right? It says right here, 340 gallons of gas and 10 gallons of oil. So that was right there for us. Anything else that's obvious? The percent of which, what percent are we talking about? Start here? What's the percent oil of this one? So, 0.025, okay. It's expected, right? Can we do that one?
We can do gas.
0.04. Can we do this one? Why? Yeah, if you look at where you are, the percent oil of oil. 100%? About this The percent oil of gas, 0.
Hopefully.
Holy cow. We only have 2 spots left.
Oh, X1's
Right? We don't know how much of the 4%, so let's call it X. We don't know how much of the 2.5%, let's call it Y. And we got our chart done. What do we do now? Multiply across. So you see what I'm saying here? If you don't pack it in at the very beginning, and you say, let me just see where I can go with this, and all of a sudden, okay, 0, 10, 0.04x, 0.025y, now you have an entire chart done, and I believe you have a pretty good idea how to come up with any equations you're gonna need. Right? How many equations do we need?
2.
Why?
There's 2.
Two variables. 2 variables, 2 equations. Any idea where the first equation is gonna come from?
4%.
The right side of
The right side, the total oil column?
yeah.
Okay. Now remember what's going on here. What's going on?
How many gallons?
Okay, before we get to making, how are we making?
Mixing.
We're mixing. We're mixing,
0.4 eggs,
we're mixing gas
oil.
and oil. So,
0.4.
now, gas,
Oh,
0, plus oil, right? We're mixing gas and oil.
Equals 0.04x.
We're mixing gas and oil to get, so what does to get equals?
And 0.4x.
Well, we're in this column. So we better stay in this column.
0.04
Oh.
eggs.
0.04x.
Okay, yeah, that's.
See, I would probably say, let's make sure that this stuff is separated so that we kind of know, these are the things we're mixing, and these are the results at the end. Yes? So if we're mixing these things, we take this and we add this, and then at the end, we're going to have this and this. But the total oil at the beginning has to equal, like if we end up, if we're mixing stuff and we find that we have 6 gallons of oil, and then we're going to divvy it up into 2 different things, what do the 2 things have to add up to be in total oil? It's got to add up to be 6. In this case, they got to add up to be 10. So total oil of what we're mixing in the first place needs to equal total oil of the mixtures that we have at the end. Is that reasonable? We need another equation.
X plus y equals 2.
From the first column, from the amount column. Does that make sense? The amount of gas, the amount of gas plus the amount of oil equals
X plus y.
the amount of those 2 final mixtures. Right, so we're mixing gas, we're mixing oil, we do what we got to do, we take some of the result and put it here, we take the rest of the result and we put it there, but these 2 results had better end up equaling what we started with. What do we have? We have our system. We have our system. Could you solve that system? No? That's a shame.
Oh yes, but what a shame.
You just add these 2 together, right? 10, 350.
Oh,
And
is that
then-
really
Oh, wait.
that's what we do?
And then what? How are you going to solve it?
Substitution.
Okay? Some people like substitution. I'm more of an elimination person. But the reality is, to be 100% honest, what I would probably do,
Graph.
being given no guidance in terms of what I need to do, I'd probably throw it in the calculator and do augmented matrices and do RREF. That way I don't have to deal too much with all the decimal garbage. Yeah. But here's the beauty of where we are. Some people said they would do substitution. Some people were thinking about elimination. I heard a few people even talk about graphing. And I'm sitting here saying I'd use matrices. Which one's right? They're all right. And that's the beauty of where we are. Well, but that's the beauty of where we are, is we have options. And your job is to figure out what's easiest for each time.
So like, actually, when they're in the real world, right, and they're actually making, like, shipping out orders, do they actually do this?
I would guess that there's some way that
It's
this
not
is
like
done.
like a system on the computer?
Now, of course, it's gonna be a lot more complex because let's say that you mix 340 gallons of gas with 10 gallons of oil, and then you are trying to make it into a 4% solution, 2.5% solution. And then you're pouring it into that, and you're pouring it into that. Now, real world, have you ever mixed stuff in a container or eggs or something like that? And then you go and you pour the eggs or whatever into whatever?
Chemical reaction.
You never get every drop out, right? So there's gonna be wasted stuff and things like that. So it gets more complicated than that. But in general, they're either doing this or they have had to create the computer technology that will do that for them. Like somebody comes up, you're talking about using the computer to do that, which absolutely, but somebody has to do that. So what are you going to be? Maybe you're the dude that writes the computer program. Pizza range.
On the desktop, 5% and how much? So that has to add up to
Even.
like,
Okay, so we have 10 gallons of oil, right? So, are you okay with the chart?
yes.
Okay. The total oil from the original gas is 0 because there's no oil in gas. The total oil from the oil is 10. Okay? So basically we have 10 gallons of oil. When we are done for the day, we're going to have 2 containers. One container is going to have a 4% oil solution. The other container is going to have a 2.5% oil solution. But somehow, if we were somehow able to siphon out the oil that's in that one and in that one, and put it all back together, how much oil would we have at the end?
It's not necessarily saying 10% or 4% of.
Correct, I agree with you, yes. Yep, cool. And here's kind of the funny thing about it. It's kind of a weird thing that we're talking about, and we're done with the problem, and we're still talking about it's weird, and I'm not really sure I understand what's going on. But we were able to answer the problem.
Yeah.
And that's kind of a cool thing. So. Well, you've got a lot to say. What's good fashion? All right, can we move on? All right.
Doing. Dying. Oh, is this really actually your say? Yeah.
Anybody still need this?
No, just cat time. Permanently.
So today,
Oh boy, it's 9:19.
the good news for today is that we are basically continuing to use the stuff that we learned yesterday. And the day before that, the day before that, and the day before that. The bad news, if you want to call it bad news, I don't really think it is, but is that we are now
Learning.
expanding to 3 variables. Now the good news, more good news, is that we've kind of already done this. We're going to talk about it more in regards to substitution, elimination, and things like that. We'll do that in a minute. But I kind of want to give you a general idea of what it is that we're talking about. What are we looking at, things like that. So when we did the 2 variable systems yesterday, if we were to graph one of the 2 variable equations, what would it look like? It would be a line, right? If we were graphing 2x plus y equals 7, it would look like a line with a slope of -2 and a y-intercept of 7. Yeah. So we know that. We know what the line looks like. And if we have 2 lines and we're trying to solve the system, what are we looking for? Where they intersect. Okay. to change. When we suddenly have 3. What would the graph of this look like?
A shape.
And at this moment, I accept the answer, I don't know. But I want you to think about it. Let me go back. Hang it. When you were in 4th grade, or 5th grade, or whatever, and you graphed x equals 5. Yes, you did. How did you graph it?
You just put a dot on the 5 and then drew a line.
You didn't draw a line.
You just drew a dot.
Do a dot, yeah.
How did, what did the graph look like that it allowed you to graph x equals 5? It's horizontal. It was simply a
dot.
what kind of a line? What did we call it?
A hard
Straight
basis
line.
one.
Here we go with the straight line thing again.
Up and down line.
Not usually up and down.
Oh,
Vertical.
horizontal line.
Yeah, it started with an N. Very simple.
Num.
A number line.
Oh, number lines. Oh,
Right,
I
didn't-
hate a number line.
Didn't you? Somebody said graph x equals 5, and what'd you do?
Dot.
You drew the number line, and then you went 5. Right? When we went to this, what did we include? Okay, so we had x equals 5, okay, and we just put a point right there. That was our graph. But then when we went to 2x plus y equals 7, what did we have to include? The y-axis. So this was the x-axis, and now we have the y-axis. Right? That's a great question. When we suddenly go 2x plus y plus
I don't
3z,
know about a z-axis.
we need a
Z-axis.
z-axis, a third axis.
You need z-axis?
Brooklyn says, where's it going to go? Not diagonal, because remember, x equals 5 was a number line.
Ow.
How many dimensions is a number line?
1.
1. It's just right and left. Okay? 2x plus y equals 7 is
2.
how many dimensions? 2, because it has
2 lines.
horizontal and it has vertical. When we have 2x plus y plus 3z equals 12, we now need a
Third dimension.
third dimension. Where would the third dimension go?
Through.
Depth. In other words, the third axis is coming out this way.
My poor
Right?
tired brain.
This room has 3 dimensions.
Yes.
It has length, it has width, and it has height, or depth, either one, same thing. So if we are to graph 2x plus y plus 3z equals 12, what will it look like? A 3D something. It's not going to be a point. It's not going to be a line. It's going to be a...
Geometry.
It's gonna be a geometry. Whoa.
What shape? What is 3-dimensional in geometry?
Circle.
I think I might have heard it, but I'm not sure.
A circle.
Starts with a
three-dimensional.
P.
No.
Get
A
more
prism.
generic than that.
A prism.
Polynomial.
Polynomial
When I
prism.
give you the second letter, you'll have it.
No, don't do the second one. It's
P-L.
Oh.
Well, because you haven't been thinking about it. Okay? But one-dimensional, on the one-dimensional axis, you're just putting a point. On the two-dimensional axis, you're doing a line, but in the three-dimensional, you have planes. And this represents a line. this represents a plane.
We have planes.
So now, when we have 3 planes on the same graph, it sounds like a mess. Yeah, there's a lot going on here. And so what could it look like?
There's
well-
too much going on.
It could look like this.
Oh, God.
Yeah, we did that in geometry.
Slicing stuff.
I don't remember that.
Nuh-uh.
I did that.
So,
No, thank you.
let me make you feel better, can I? Okay? We are not gonna have to graph any of this stuff.
I feel
Did I make you feel better there?
So
Yes.
much better.
But hang on. What I want you to do is kind of understand at least a little bit what it is that we're talking about. Okay? We could have 3 planes. We could have the red plane and the blue plane and the green plane, and they're all kind of meshing out there, and they intersect at one point. This is the only point where the blue, the green, and the red are all true at the same time, and it's at that point, and this is what we normally see, right? Because we usually, when we have a system of 3 equations, we end up with one solution, okay? But that's not always the case. We could end up with no solution. Now, if we were back in the 2-dimensional world, and we had 2 lines, and there was no solution, tell me about the 2 lines.
Parallel.
Have to be, right? There's no other way that we can have 2 lines that never intersect unless they're parallel. But when you start getting 3 planes, yes, you could have 3 parallel planes, but you could also have 3 planes where plane A intersects plane B, and plane B intersects plane C, and plane C intersects plane A, but they never all 3 intersect at the same place. You see how that can go?
Yeah.
So no solution here probably pops up a little bit more often than it does when you're dealing with lines. Because you've got a couple of different options, and this can absolutely happen here. Fair? You can also, when we dealt with lines and we had an infinite number of solutions, what did that mean? They were the same line. They were coinciding lines. One line was on top of the other. They were the same. However you want to phrase it, it was the same line. That could happen here also. But more likely, you have 3 different planes and they all intersect. But look where they all intersect. And they all intersect at this spot. It's kind of like the pages of a book. Yep. Where you have... Can I steal this for a second?
Yeah.
Okay. Where you kind of have one more, there we go. Where you have 3 different planes. Okay? Because a plane is like a piece of paper, right?
Yep.
So if you have plane A, plane B, plane C, where do they all intersect?
And the binding
At the binding. And what does the binding basically look like?
together.
It's a line, right? Now, are these 3 planes the same?
No.
Of course not.
Oh, just kidding.
Well, they're 3 planes, but they're not in the same place. We got this one over here, we got this one over here, we got this one over here. But the way they all meet is right here on this binding.
I don't want to lay on that.
How many solutions would there be? Thank you. There would be an infinite number of solutions along the line. Okay? And so the line of intersection would be the infinite number of solutions. Does that make any sense? Now, the good news is you don't really have to worry about all of that with what we're about to do. But I did kind of want to show you what it is that we're really talking about while we're doing this whole 3-dimensional stuff. It takes on this whole added dimension. There is. It's called time. We're not going to really, we would never pay attention to that.
We're
Like,
going
we
to
can
graph
solve a
time.
4-variable system, which you already did. Right?
Yeah, I got you.
Just a couple days ago, you dealt with a 4-variable system with the touchdowns and the field goals and the extra points and the safeties in the Super Bowl. But did you have to comprehend 4-dimensional space and time to be able to do that problem?
No.
No, you just have to be able to plug it in the calculator and solve a system of equations. But hopefully by showing you a 3-variable system and how the planes can intersect, hopefully it kind of gives you a little more awareness of what it is we're talking about.
So I feel like the talk method would actually solve like the area of a triangle in time with like 4 dimensions.
That makes good.
Could you do that?
Sure.
Oh, it's so
How would you
fabulous.
The
right
area of a triangle in
Right.
time. Well, unfortunately, a triangle is only
Get back to my
2-dimensional.
face.
Okay,
So we'd have to get to a 3rd dimension before we got to a 4th
So the
dimension.
area of a cube is in a certain.
The area of a cube, the area of a pyramid.
Jesus.
And that's why all of these things
That was
meld together.
terrifying, mildly.
And that's why physics is very
No, I'm great,
math-based.
but not
And
Jesus.
unless you go pure math, you're probably going to have some type of science
Although
involved.
I've
and
been
things
told
like
the
that.
resemblance is striking.
All kinds of things that you have to do. I mean, I was a computer engineer. I had to deal with the math side of things. I had to deal with the science. I had to programming. What was it that I was going to program? There was all that stuff out there.
Physics, yuck.
But that's why all of this stuff meshes in the real world.
I know, I just don't understand how it's like there's so many different options. It's so hard to figure out how it works.
And what's going to happen is, shh, please, when you move on to your next world and you start to decide what it is that you want to work in, you don't, you can say, well, I like math, so I'm going to be a math major. Or I like biology, so I'm going to be a biology major. But even in biology, there are 32 different directions you can go. And so no matter what it is, like you may say, I don't like history, so I'm not going to do anything dealing with history. Or you can say, I don't like math, so I'm not going to do anything dealing with math. And all that's fine. But the odds are that somehow, some way, some of it might still filter into what it is you're going to do by the time you're 35 years old. All this stuff comes in. And so, when people say, well, I don't like English, so I don't want to have to do English when I go to college. You're still going to have to read, yeah. And there's still, the likelihood of there being some commingling of all of these subjects in the real world is pretty high up there. I know I was talking to somebody the other night that is a game programmer. Okay? But he programs games that are educational.
Oh.
That's disappointing.
I have a
So
respect
he
for game
deals with
developers,
games
but-
that are like National Geographic types of things. And he deals with schools and stuff like that. The number of people that he works with, specialists in so many different areas, you wouldn't even think about it. Like you think, oh, I just want to make a game. But let's say that you're not doing a game that's educational. Let's say you're doing